Hello students, welcome to the series of lectures on digital speech processing. So in this video I am going to explain about the classroom discussion topic of speech versus silence discrimination. This is a very important topic because when you speak anything and we need to identify what is the speech signal and what is the silence signal. Okay, after drawing the time domain representation we can easily identify that from the pictorial representation. Okay, let's get started. So on completion of this lecture, you'll be able to illustrate the speech versus silence discrimination using energy and the zero crossing. So these two things that we already seen in the previous videos. So once you watch the two videos so that you can easily understand. So this topic is that speech versus silence discrimination using energy. So the main important consideration for discriminating speech and silence is that so we need to locate the beginning and end of a speech. Okay, so on a given time frame of 5 seconds, for instance, if you speak for 5 seconds, and we need to identify what is the beginning of the speech and what is the ending of a speech. So the locating the beginning and end of a speech occurs in the environment with background of the noise. Okay, so because mostly we cannot speak in a clearly environment. Okay, so we'll be speaking in a background environment like so when any fan is running in a room or when you travel on a footpath, there's so much of background noise that is coming from the vehicle and everything. And even when you travel in a car also, engine noise will be there, and if you want to speak to somebody else, so there is a background noise is also going to be accompanying. Okay, so the first and foremost is that we need to locate the beginning and end of a speech utterance in the environment with the background of the noise, and where we can use this kind of an application. So the main kind of the application is the segmentation of the isolated words and automatic speech recognition. This is also a very important area where the research is going on. And the another important application is that we need to save the bandwidth for the speech transmission. Okay, so once we clearly identify what is the beginning and end of a speech, we are going to be saving the bandwidth for the transmission of the speech for the further uh, processing of the speech. So in some cases, we can locate the beginning and end of a speech utterance using energy alone. And you can easily identify from this slide is that I have mentioned one representation of the time domain. So this is the tape 8 actually. Okay, so we can easily identify what is the begin of a speech, because before that there is no pictorial representation that can be possible. Okay, so that is the beginning of it. By taking the computation of the short time energy, and we are going to be calculating the magnitude by using the rectangular window that we already seen in the previous video, and this is the way how we can easily locate the beginning and end of a speech utterance using energy alone. And in other cases we can also locate the beginning and end of a speech utterance using zero crossing rate alone. Okay, this is zero crossing rate alone. Okay, and when you watch the previous video we can easily identify how we need to take the zero crossing rate. Okay, by taking the magnitude and how we are going to be processing the transmission of the speech signal. Okay, and sometimes we cannot do it using one criteria alone. Okay, there should be some mixing of the two criteria will be taken into consideration for locating the beginning and end of a speech. So this is a mic 4, this is an actual beginning, but there is a change that you can easily observe from this. The point A is actual beginning, but we are going to be calculating from point B. Okay, that is some background noise is also going to be accompanying. Okay, so what is the difficulties actually? In general, it is very difficult to locate the boundaries if we encounter the following cases. So these are the cases that I have mentioned in the slide. There should be some difficulty in order to locate the beginning and end of a speech. The first important difficulty is weak fricatives at the beginning or the end of a speech utterance. So weak fricative nothing but when any word that is starting with F or TH or H. These are some of the examples I have mentioned in this slide. So these I am calling as a weak fricatives. If there are weak fricatives, we are unable to locate or we are unable to identify what is the beginning and the end of a speech. And the second case is that weak plosive burst. Okay, at the beginning or end of a speech utterance. So like P, any word that is starts with or end with P and T or K. So these are the three important letters I have taken. So these I'm calling as a weak plosive burst, and the nasals at the end, and voiced fricatives which become devoiced at the end of the words, and the trailing off of vowel sounds at the end of an utterance. So these are the total 5 important cases we are going to be looking here. By using these 5 cases, we are unable to locate what is the beginning of a speech and end of a speech. But what is the solution for this? So there is a solution. Okay, the solution is that Rabiner and Sambar, they have created one algorithm. Okay, so despite the problems cited about the situation in the previous slide, the combination of energy and the zero crossing ray representation are suitable for developing a useful algorithm for locating the beginning and end of a speech signal. So these two scientists have worked on this, and they have created one algorithm, that is Rabiner and Sambar have presented one such algorithm in the context of an isolated word speech recognition system. Okay, in the unit number 4, there you are going to be studying this topic, isolated word speech recognition system. So in this system, what is happening is that a speaker utters a word during a prescribed recording interval, and the entire interval is sampled and stored for the processing. Okay, which is quite very simple for us to understand. This algorithm states that, so if any speaker wants to speak something, and during the period of interval, the entire interval is sampled and stored for the processing. So basically this algorithm has taken a step. The algorithm makes use of the 10 millisecond frame and a sampling rate of 100 times per second that can be used. So 10 times of the frame that we have used as a sampling rate. And it starts with an assumption that the first 100 millisecond of the interval contains no speech. So this is an assumption. This is the flow actually we need to understand for the algorithm. So in order to understand the Rabiner and Sambar algorithm, so what we need to understand is that it starts with an assumption that the first 100 milliseconds of the interval contains no speech. And after that, we are going to be seeing the speech, so that we can easily, it is very easy for us to identify, because in the first 100 milliseconds of the interval, it contains no speech and there is no important information that is contained in this period. And after completing 100 milliseconds of the interval, and we are able to locate the beginning of the speech and similarly end of a speech utterance. This is very important algorithm we need to identify. Okay, so the problem whatever that we have seen in the previous slide, that can be eradicated with the solution of this algorithm. This is a very important algorithm, so that we can easily locate the beginning and end of a speech signal. Thank you, student. Thank you for watching this video.